So how is this translation provided? So we have the machine name like A/B/C. How is this translation done from the machine name to the network location? We use something called a domain name. So we use something called a DNS to switch mapping, which provides the translation, right? And when we start Hadoop, before we start Hadoop, we have to configure this network topology and let Hadoop know about this topology. Basically, we have to specify the name of every node and so on, right? So we specify that through a script called topology.script.filename, right? You can write a quick Python script or something, or a shell script to which the input will be the mm, to which if the input is something like A/B/C, or sorry, to which if the input is the IP address, it will return something in the form of A/B/C, right? And the distance is computed as the sum of the distance from the common ancestor, like we discussed. So if the input to the script that you have given is something like 192.168.1.1, it will return back something like 192/168/1/2, right? So for these two IP addresses, the distance, so basically it will compute the distance to the common ancestor, and it will give you the distance between the actual distance between the two nodes, correct? Okay. Okay. So quick question here, right? So what is the distance between uh, data set? So D's basically depict data centers, R depicts racks, and N depicts nodes, right? So what is the distance between data center 1, rack 1, node 1, and data center 1, rack 1, node 1? So if the process is running on the same node, what is the distance? Okay, 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 great, great. So the distance is basically 0, right? Because the process is running on the same node, there is no distance. What about the second case? D1, R1, N1 followed by and D1, R1, N2. What is the distance between this? This is basically different nodes on the same rack. Think about the common ancestor thing that I just said. Okay, some of you say 2, some of you say 1. Okay, so take a look at this slide again. So the distance between node 1 and node 2 is the distance between the distance of each node from their common ancestor, the sum of the distance of each node from their common ancestor, right? So distance between node 1 and rack 1's switch is 1. Distance between node 2 and rack 1's switch is 1. So the entire distance is 1 plus 1, which is equal to 2, right? So it's the same case here. So see, N1 is on one node and N2 is on the same, N2 is on the different node in the same rack, right? So the entire distance is 2, because the distance from the common ancestor is 1 plus 1, which is equal to 2. So Dayanand and Vijay, did you get the point? Did you understand how is it 2? Dayanand, do you understand how is it 2? Okay, great. What about the second case? The distance between D1, R1, N1, comma D1, R2, N3. So note that the processes are on different racks, but in the same data center. What is the distance between these two nodes? 4. Right, right. Because the distance between the common ancestor Yes, so the distance is 6. It is not 8. Why is it 6? So think of this entire slide, the picture in this slide as one data center, and imagine that we had another similar picture, right? And the two switches are connected by another switch. So the distance of node 1 to that switch on the top will be 1 plus 1 plus 1, 3, and similarly for the other side. So it is 3 plus 3, which is equal to 6. Do all of us understand why is it 6 and why is it not 8? Okay, okay, great. So basically, HDFS makes use of this rack awareness algorithm to optimally place the nodes in in two different racks. It maintains two copies on one rack, two copies on two different nodes in one rack, and one copy on another rack. The replication factor is 3, and it basically makes use of data locality optimization. Tries to run the map task on the node where the data is available, right? So, Srilina, yeah, the two data centers are connected by one more switch. So, for the purpose of this question, we can imagine that the two data centers are connected by one more switch, not a hierarchical uh, layer of switches, right? So, any questions in for this basically this session, the session on MapReduce? Any questions on the MapReduce session? Uh, So Achinta is asking, is it possible that out of three replica of data, one can be on a different data center as well? Yes, that is possible based on the replication factor decided, but usually the case is that the data is kept on a different rack. So usually it is within the same data center. Right? So usually it is on the same data center but on different racks. When a new rack is added to the data center, does HDFS automatically distribute the data to new rack, or we have to do it manually? So then HDFS basically uses a rack awareness algorithm and it tries to store the data within the same data center in two different racks, right? So the data is on the same data center, the data is on racks in the same data center. So the question ideally should be that if you introduce a new rack in the data center, will HDFS automatically distribute the data to that rack? it will not do it automatically unless you include that rack into your network topology. So you have to specify that you want to use this one more rack in the network topology, only then it will use it. Otherwise, it is not going to use it. So you have to configure this entire network topology. So for every node, HDFS basically invokes the script that you have specified using the topology.script.file name. If, however, this file name is not set, which means you have not written a script, it will take the default ID as the default rack. Sorry, it will take the rack ID as the default rack for any IP address, right? So basically, then it doesn't know about the rack. With gigabit connection between the racks and the data center, the delay should be minimal if the block has to be moved to another rack, correct? Yeah, the delay should be minimal. Usually the network speeds are very good. The bandwidth is really, really good, and it is very fast to move the data or copy the data from one rack to another rack, right? But this is done so basically to be from a point of view to be more fault redundant rather than to be faster. So what do we mean by fault tolerance? Sorry, it is done to be more fault tolerant. What is fault tolerance? If one copy, if basically say there is a fire in, there's a fire or something like that, and one copy goes away, right? So one rack goes down for some reason, we have another redundant copy of the same data. Right. Also, rack outages are much less frequent, right? But to be on the safer side, it copies the data into multiple racks. Okay, great. Any more questions around rack awareness or map reduce in general? Okay, so I will start with the pig session, right? Okay, so if you have any follow-up questions from whatever we discussed until now, please feel free to ask, right? Okay, so what is pig essentially, right? We already spoke about writing Java code, writing MapReduce in terms of Java, right? Why do we need another engine? Why can't we just keep writing MapReduce in terms of Java? So what we saw is that writing MapReduce in terms of Java is not very straightforward. A lot of boilerplate code is needed. We need to write the mapper class, the reducer class, and we need a lot of other things. The code is not very straightforward. It is not very straightforward to implement complex algorithms in terms of Java MapReduce, right? So another engine was introduced, right? So another engine called pig was introduced. So what is pig? Pig is essentially an engine which will take your query and it will convert your query into MapReduce tasks internally, right? So when you fire a pig query, the query looks very simple. It is more like, in terms of SQL. So when you fire a pig query, the engine the engine behind the scenes will convert this into a MapReduce process, and it will execute it on Hadoop, right? So Pig is basically a high-level language for expressing data analysis programs. It is basically a high-level language. The language that we use, so Pig is called the engine. Pig is known as the engine, and the language that is used is called Pig Latin. But we will use Pig Latin and Pig interchangeably, right? So Pig provides us with operators which are very similar to SQL. So it provides us join, order by, filter, group by, and so on. So it is very, very similar to SQL, and most of us are very comfortable writing SQL queries, right? Also, Pig is very easy to it is very easy to program in Pig. It takes only a few okay, it is very easy to code in Pig. It takes only a few lines to write to express your problem in terms of Pig rather than when doing it in Java, right? So it is much more easy to write, and it is very much like SQL, right? Okay, okay. Also, Pig runs on Hadoop, and it makes use of both HDFS and MapReduce. So under the hood, it converts your Pig Latin statements into MapReduce problems, and it reads the data from HDFS. So basically, Pig is very compatible to run on the Hadoop ecosystem, which includes HDFS and MapReduce, right? Okay, so this is the word count example that we have been discussing until now in all our previous sessions. If you don't understand the syntax right away, don't worry, we're going to go into every single line much more in detail, right? So what we do in Pig is basically we first load the input data. So big.txt is where the data is available. So we load the input data, right? And then we break the line into words. So the big.txt is composed of multiple lines. So in the second statement where we say for each input generate flattened tokenized line as word. So we are basically just converting these lines into words. Then we are grouping the words. So we are grouping the output of the previous statement by word, and then we are just doing a count of the words, right? For each so after we grouped, we are just doing a count, right? So we see that in case of Hadoop in case of Java, we had to write a lot of code, but here we can achieve the problem in very few statements. So it is very much like SQL syntax. We will discuss every statement in much more detail, right? Okay, so Pig basically is a data flow. It's a data flow language, so it helps you describe how the data flows. Like in the word count example, we say that this is the input, then break the inputs into line, then break the input into words, and then group the words, and then count the words, right? So you can specify how the data flows, right? You specify how the data should be read, from where should the data be read. You mention the input file, how the input will be broken into words, and so broken into multiple based on what problem you are trying to solve, how the input will be broken, etc. And you then specify how the data should be processed, and then you can store the outputs in parallel. We will discuss more about how we can do it in parallel, but we can store the output in parallel. So Pig is more of a data flow language. You can read the input, then you say how will you process the input, and then you put the output back into HDFS, right? Pig is very suitable for complex workflows, right? So Pig was primarily written for complex workflows, right? So when you have to join multiple inputs, and when the data has to be split, etc. So Pig was primarily written with the use case for complex workflows. It is very difficult to express complex workflows in terms of MapReduce Java. So that's why Pig was essentially introduced. Okay, just give me a moment. Right? So, okay, so what is the basic difference between pig Latin and MapReduce? Right? So pig provides us with very SQL-like constructs like join, filter, group by, order by, union, etc. Whereas in MapReduce, all these operations are pretty hard to do. Writing even basic joins are a little tough in MapReduce, right? So if you want to do like very basic joins, even that is pretty difficult. That is pretty cumbersome to write in MapReduce. Also, pig understands your script. Okay, so pig is a self-optimizing engine, right? So pig basically understands what are you trying to do, and it will try to self-optimize. It will try to rebalance the reducers, etc. Whereas in MapReduce, you will have to explicitly specify all those optimizations, and hence it becomes a little tough, right? So in pig, you understand. So pig basically understands your scripts, right? So as soon as you say that like in the previous example, here, as soon as you say grouped grpd is equal to group words by word, if words is not available, if this variable words is not available, it's going to throw you an error up front, right? So pig basically understands your scripts, whereas in whereas in Hadoop it doesn't understand, right? So basically, for example, in MySQL also, when you say that select column 1 from table 1, if column 1 is not available in that table, it will throw you an error upfront. But in case of Java MapReduce, what you have to do is you have to write the code, then export it into a jar, then run your code, then you will see the errors. And then you go back and fix it. So there is a lot of to and fro. A lot of iterations are needed when you are coding MapReduce in Java, right? Obviously, pig is the cost to write and maintain the Java code. To maintain the pig code is much lesser when compared to Java, because it is so easy to write pig. So basically, it is very easy, and hence it is much more maintainable. In case of MapReduce, it takes a lot of effort and time to do this. Pig programs can be expressed in very few lines. So something that you can write in 9 lines in pig, you will need around 170 lines in MapReduce. However, pig has some limitations because you don't have a lot of granular control. It is more of a language, and you have to use the language constructs. So pig has some limitations, whereas you have a lot of control when you express your problem in terms of Java MapReduce, right? Example of what, Akshay? How pig is easier than Java MapReduce? Yeah, so this is basically what I was trying to explain in this slide. So here we could do the word count example in just 4 lines, right? We specified input, we then broke the input into words, we grouped the words, and we counted them. So okay, so in Java, for example, you can specify the comparator function, you can specify the partitioner, etc., etc., right? So that essentially gives Java a lot more control than Pig. Pig comes with a specified set of input types, etc., but Java obviously has a lot of control because you can specify things like yeah, you can specify your partitioner, you can specify your comparators, etc. Okay, but a point that I would like to bring up here is Pig also tries to give you, although Pig has some limitations, but Pig also tries to, it is also pretty extensible. It lets you write your own functions. So it is like you have this group by, filter, union, etc., etc. But since, say you want to come up with your own function, Pig lets you do that. Pig lets you write, lets you have Pig lets you write your own functions, which are called user-defined functions. These are for special purpose processing, mostly for special purpose processing that some operators that Pig doesn't give out of the box, and if you need them, you can write them on your own and then use it with Pig. So that is called user-defined functions, and we will discuss that in the later slides. Okay, so Pig Latin versus SQL, right? So in Pig, you can describe how the data needs to be processed. You specify that, this is my input file, this is how I will break my input file, this is how I want to group, etc., etc. But in SQL, you don't do that. You basically just ask a question. You just describe what question you want to ask. So you already have the data in one column, and you just say that. So in SQL, essentially the logic revolves around a single query, whereas in terms of Pig, you can have multiple queries. So in case of you can, in Pig you can have a long series of data operations, whereas in SQL you just fire one query. However, if you want your SQL to have multiple queries, then you will have to use something called views in SQL, which becomes very complex. Right? Also, Pig is designed for Hadoop. Pig was designed for distributed systems, and SQL is not designed for distributed systems. It is designed for relational databases, relational database systems, right? So for if you want to operate on multiple data sets at a given time, Pig can do that for you. It can do parallel processing. It can read multiple data sets. But in SQL, this query is going to get really, really complex. Also, Pig can work with unstructured, semi-structured, and structured data, whereas SQL works only with structured data, right? So that's the basic difference between Pig and SQL. Okay. Uh, so Dayanand is asking, in case of MapReduce, we have to define input file format for input splits. Does Pig already take care of input splits? So, Dayanand, the split size, etc., are more of a function of Hadoop. Uh, the MapReduce paradigm, right? So you have to specify the input split size, etc., using the using properties like mapred.min.splitSize, mapred.max.splitSize. So I don't cannot think of the exact property name from the top of my head, but those are more of a Hadoop Hadoop MapReduce properties, and you can specify them explicitly when you are bringing. So basically, when you are configuring Hadoop, you can specify that. Also, if you want to specify specific input formats, etc., you can do that in when you write your this thing. So we will look at the load. We will look at the load and the store methods. right? And the load and the store APIs in Pig are aligned with Hadoop's input format and output format classes, and you can use those to specify the input format, output format. So you can you have to do that explicitly. If you want to specify a specific, if you want to use a specific input format, Pig gives you that control, right? So when you're actually loading the data or you're storing the data, you can specify the input format as well. Right, so the load and store functions basically give you the ability to specify the input format, output format as well. Okay, so what are the use cases that Pig is basically used for? So Pig is more used for ETLs. What does ETL stand for? It is called extract, transform, and load. So when you want to, extract the data, you want to reformat the data, and then you want to load the data back into some data store, Pig is more suitable for such use cases. When you want to do some sort of a research on raw data, then Pig is a suitable option, and also it is more suitable for iterative processing. So Pig is basically designed for performing a long series of data operations, right? So you can have a long series of data operations defined in Pig very easily, and hence Pig is more suitable for batch processing. So Pig lies somewhere in between SQL and MapReduce. So in SQL, you basically work with a single data set at a time, whereas with Hadoop MapReduce, it is much more complex to write the queries, etc. Pig basically lies in between these two, and it is very suitable for iterate batch processing. We already know that Hadoop is designed for batch processing as well, and Pig sits on top of Hadoop, and hence it is also used for batch processing. Right? So what is the philosophy of Pig? The philosophy of Pig is that Pig eats anything, right? It will work with structured, unstructured, semi-structured data, anything. So Pig basically eats any sort of data. Pig lives anywhere, right? So Pig was initially designed for Hadoop, but now Pig is they're making Pig compatible with Spark as well. Also, right? So it is not restricted to Hadoop. It can work with Spark as well. So we know that so pigs are domestic animals, right? So you have a lot of control over pig. It provides you custom functions. You can write your own functions and then use them in your pig code. So it provides you. It is very controllable, right? You can have custom load and store methods also. Like I just mentioned, you can specify the input and the output format. So it is very controllable. Also, pigs fly. So pig is designed for performance. Pig is very, very performant. So pig is gonna eat anything. It will work with any sort of data. It's not only designed for Hadoop. It is designed. It is a parallel processing language. It can work with Apache Spark as well. Pig is very controllable in terms of the custom UDF functions that they give you, and it is designed for performance. Okay, so to install Pig, you can download the Pig from the Pig release page, and untar the gzip that you get. You have to move this thing into user local pig, set up Java home, etc., and set up the pig class path. right? And you're good to go. So you can run pig in two modes. You can run pig in local mode and then in the Hadoop mode, in the MapReduce mode, right? So when you say pig -x local, you run pig in the local mode, and there you can do any you can run your pig queries on test data to see if things work. So pig in the local mode is used primarily more for testing, right? And so once your local setup is working, you're good to go. So let me quickly show. So this, I am logged on to the one of the machines. So here if I say pig -x, okay, before that, let me just do a ls, right? So we see that there are these files in the local file system of this machine. When I say pig -x local, right? So this has started pig in the local mode, and when I do a ls here, I will see the exact same files that I was seeing here, right? So we have this exact same files. So we can use pig in the local mode as well. Okay, great. So this is what I was essentially showing you. If you want to use pig from, if you don't want to, set up your own stuff, uh, you can log on to any of these machines, and you can just say, so if you want to do a pig -x local, you can do this. Let us exit out of this, sorry. Right, if I say just pig, then it runs pig in the MapReduce code. In this case, it is going to talk to HDFS, right? So here I can say ls again. Right, and this does a ls on HDFS, right? When we were running pig in the local mode, it was doing, and we did an ls, it was doing a ls for the local file system. In the MapReduce mode, when we do a ls, it does a ls on HDFS. Almost all. Yes, Achintya. Local here means it is the local Hadoop 1, Hadoop 2, 3, 4 box, not HDFS. So that is the local. So when you say pig -x local, and then you do a ls or you do any other commands, it's going to work on the local file system. It's going to read the data from the Hadoop 1 box, what is available on the Hadoop 1 box. But when you say just pig, and when you and if you run the pig prompt using just pig, then it runs it on the MapReduce mode. In that case, if you do a ls, it will basically list the files from HDFS. So here when I did a ls, it is showing me the files from HDFS, whereas when I was doing a pig -x local and I did a ls, it was from the box. I am on the Hadoop 3 box, right? So it was on that box, and if I just say pig, it starts pig in the MapReduce mode, and when there I do a ls, I see the files from HDFS. Okay. Uh, so the prompt is called grunt. So this is the prompt. It is called grunt, and almost all the simple basic Unix shell commands are available. For example, if you do a pwd, you can see that it is reading from user student, right? You can do a mkdir, you can do a cat, right? So okay, so for example, we have this test.txt, right? So if I say cat test.txt, okay, this doesn't have any data. Let me see this one, test file.txt. Okay, so it shows some data. So essentially, it is doing a Hadoop fs minus cat, right? It is working on HDFS, right? Any confusions between running pig in local mode versus running pig in MapReduce mode? Are we all clear how pig local or and pig in MapReduce works? So when you do a local, you're actually talking to the local file system. When you say pig, just pig, in the MapReduce mode, you're talking to HDFS. Are we all clear with that? Can I get a yes or a no? Okay, okay, great, great. So all the data that we are going to work with in this session is uploaded to user student data. Okay, so we already spoke about this. You say pig minus x local. It will work without a Hadoop installation. You don't need a Hadoop installation. For that, it is very useful for testing locally, right? So you can, it basically improves the development pace. MapReduce is not going to be, a mapper, a reducer, blah, blah is not going to be fired each time. You can quickly work on sample datasets in the local mode. So it is very useful for testing. Okay, so I just showed you how to run pig in the MapReduce mode, but if you write your pig program in terms of a pig script, then you can just run it like this. If you say pig followed by the file name, right? The extension of the pig script is always .pig, right? So you say pig. Suppose your file is called word count, so you say pig space word count.pig, and it's going to run your pig script. If you want to execute a single line command, you can also say something like pig minus els instead of going to the command prompt and doing it. You can check the version of pig installed on your machine by saying pig minus version, and for more options you can say pig minus h. Okay, so grunt is the prompt. This is the prompt where all the commands are typed. We're going to use grunt today for almost all our pig examples. You can also control Hadoop from here, right? This is what I showed you. You can control the HDFS from here. You can say ls or cat or mkdir, etc. So you can control HDFS from here. You can kill jobs from grunt, right? And you can also run pig scripts. So you can say exec and the name of your script, and it is going to run the pig script from the command prompt itself. Okay, so what happens in pig is, so every time you load data, the pig basically treats it as a new data set. Right, so each processing step results in a new set. Although it doesn't store it or something, but it basically treats it as a new data set. So every time you process something, you have to put it in some other variable and then process it again, and so on. Right? Pig is case insensitive, so you can use capital, you can use uppercase, lowercase, and so on. It is case insensitive. However, when you write your own UDFs, UDFs is the only exception to this rule. UDFs are case sensitive, right? When you want to write multi-line comments, you use something like this. So you use right. So this becomes a multi-line comment, and this is a single line comment. If your comments are going into single lines, you use sorry, my bad. You don't use this. You use something like this. So you specify your single line comments like this and multi-line comments like this, right? So when you're writing your UDF, it is a very good practice to always have good comments in your code. So this is how you write your code comments. Okay, great. So let's look at the first pig script that we are gonna work on today. So there is a data set called NYSE dividends, right? So this is how the data set looks like. It has 4 columns, and the columns are separated by tab, right? So the first column basically denotes the name of the stock exchange. The second is something like a ticker, right? The third is the date followed by the value. So the problem that we are trying to solve today is we want to find the average of the values for every ticker, right? So for CPO, we want to find the average. For CCS, we want to find the average. For CIF, we want to find the average, and so on, right? So this is what we want to achieve today, and let's start writing the pig script. So what essentially happens is, the first thing that you do is you load the data, right? You specify pig that this is my data path and this is the name of my columns, right? So this is what you say, divs is equal to load data from NYSE dividends as, so you give all the 4 columns some name. So you say name, ticker, data, and value. You can do a dump divs to see what actually. Okay, just a second. So let's run this. Let's also run this simultaneously, so that will give us an understanding. Right, so see, it has not done anything. We have just told it that this is the location of my data. Now if I say a dump divs, we will discuss about dump command. So when we say dump divs, it's going to actually give me the data. It will dump the data on std out, so it will show the data on std out. So after this runs, we will see that the data is basically shown on the std out, right? This is followed by a explained. So okay, let's first do this. Um, okay, so looks like this is a big file. It's going to take some time, right? Okay, so we want to find out the average for every ticker. Okay, so we see that when we just ran divs is equal to this command, right? Nothing really happened. Yes, Sharad, tab is considered as the default separator. If you don't specify a separator explicitly, we will see how you can specify a separator explicitly. But if you don't do that, tab is considered as the default separator, right? So when we just said divs, nothing really happened. We are just informing pig about, this is my input file. But when we are actually doing something on that file, this is when pig actually takes time. Right, so when we said dump divs, we are actually instructing pig that dump the data of this file on std out. So that is when it actually invoked the mapreduce command. Okay, so this is the, I did a dump divs and this is the output. I can also do a explain divs. It is just gonna quickly explain me what divs contain. Right, so it says uh, so here, right here it says, name byte array, ticker byte array, date byte array, and value byte array. Right, so it basically shows you, what the data contains, etc. So a good thing to note here is we will see that byte array is a type of a data type in pig. Here when we were loading the file, we did not specify any data type, we just gave the column names. So pig decided on some data type on its own, right? Anyways, we will discuss about all of this. Let's just quickly run. Okay, so we are saying group divs by ticker. Okay, so suppose we had to find out the same average value of every ticker using MySQL. What would the query look like? Can any of you give me what would the, so suppose this was the table and the column names were name, ticker, data, and value. What would the query look like in SQL? If you guys are comfortable writing SQL, can you give me the query? Okay, correct. So the query would look something like select uh, ticker comma average of value from div group by ticker. Great, great. So most of you got it correct. I'm very happy that most of you are comfortable in writing SQL queries. Okay, so we did a group by ticker, and now we are saying for each of these groups that you, okay, sorry. So, okay. Now we are saying that for each of these groups, generate the average value. Okay, we will run this query in details in the following slides. No point running it right now when I have not explained the name of each the purpose of each of these keywords like generate, for each group, etc. So I will come back to running the same average problem, right? Okay, so this is how okay, or just let me just run it. I have run it so far, so okay, so now okay, so this file already exists. Let's say data output hyphen 4th July, right? So basically what we did is we loaded the input file, then we did a dump div just to show what is the output, how does it load the data. I also showed you how what does the div actually contain. So we did explain divs. Then we group the divs by ticker. That's what we do in MySQL also, right? We say group by ticker, and then for each of these groups we said generate group comma average of value. So that's what we essentially did in MySQL. In SQL also we did select average value comma ticker, right? So we're doing something similar here, but when we were running those queries, nothing was essentially happening. But as soon as I said the store, it started the MapReduce code, right? Okay, okay. So now the MapReduce code is done. Let's see what it has. We call it 4th July. Okay. Let's see if this thing has anything at all. Okay, it has. Okay. So let's see what this file contains. Okay, my bad. I am not doing a cat and right. So this contains a average value. For every ticker, we see that it gives us an average value, right? So this shows us how MapReduce is how Pig is very similar to uh, so this essentially tells us how Pig is very similar to SQL, right? Also, a good thing to note here is when so each of the steps that we ran in the previous in this problem, it was not taking time, but when we say store, this is the point where the actual MapReduce phase starts. The actual mappers and the reducers, etc. start, right? So this was a very quick explanation. We will go over it, so don't worry if you don't understand something. Okay, okay, quickly. So Pig has some data types, right? Predefined data types. The simple data types are int, long, float, double, char array, byte array. What is char array? Char array is essentially an array of characters. So it is a string. Byte array is also array of bytes. So basically it is the data in its most raw format, right? So since in the previous problem we did not specify the specific data types, Pig just assumed everything to be byte array, right? So these are the complex data types. The complex data types include map, tuple, and bag. What is a map? Map is essentially a collection of key value pairs. All of us know what maps are. So the maps are the same thing in Pig as well. It is a collection of key value pairs, right? Keys are always strings. So you have to remember that keys are always strings in map. It is followed by a pound sign and then followed by the value, right? So the key is a char array, it is a string, and the value can be any complex data type or any scalar. The value could be anything, right? Okay, and also maps are denoted by square brackets. A tuple is basically a ordered collection of data. So you can think of tuple as rows in a rows in a SQL table, right? So it is composed of a lot of fields, right? So a single row from a table is composed of a lot of fields, a lot of columns. You can think of tuple like that. So it is made up of fields and their values. Uh, okay, and you can refer the fields by the position as well. So you can say 0, 1, 2, 3. You can use that to map to column field 1, field 2, and so on, right? So this is an example of a tuple. So we see that the first Bob is a char array, 55 is an integer, 12.3 is a float, and the other name Bob age 55 is a map. So all the values in a tuple need not be of the same data type. They can be composed of scalar data types as well as complex data types, and they are separated by commas, and round brackets are used to denote tuples. Okay, okay. And what is a bag? Bag is basically an unordered collection of tuples, right? So you can think of bag as a set of rows from a table, right? So tuple is a single row, whereas bag is a set of rows, right? Bags are denoted by curly braces, and the tuples in the bag are separated by comma. So RAM 55 12.3 is a tuple, the other part is a tuple, and all of these tuples are contained in a bag, right? So this has two tuples, each with three fields. So if you have a very huge bag which does not fit into memory, it's okay. Pig essentially splits the data into the disk if it does not fit into memory. Pig is not very particular about data type. If you don't specify the data types, Pig is gonna, do a very the best guess that it can do. It will do that and find out specify the data type on its own. Okay, so right. So Pig is not very particular about schema. You can also skip the name of the columns, right? So in the previous example, we said load NYSE dividends as name ticker and so on. You can in fact skip that part as well. So you can either tell Pig upfront something like this, that exchange is a char array, symbol is a char array, date is a char array, and dividend is a float. If you don't if you don't mention it, it will make the best guess based on the data, right? For complex, so for simple data types, this is the declaration, right? Exchange colon char array, symbol colon char array, and so on. But for complex types, the declaration is something like this. You can just specify a and not specify the complex data type, or you can specify a colon map square brackets. If you want to be much more specific, you can also specify what is contained within the map, right? So you can say a colon tuple x comma y, or you can also specify the data type of x and y, right? Okay. Also, you can cast the data from one type to another if possible, right? So if you say you have a string which is 12 in quotes, right? But you want to use it as an integer, you can also use typecast, the way we do typecast in Java, right? So you can do that by you can do that some so say you have a equals 12, but if you want to use it as integer, you can say int a. So pig is then gonna use it as an integer if pig is able to convert it. But if you say pig is a is equal to abc and you say int a, then definitely it's gonna give you, sorry, if you're gonna say something like int a, then it is gonna give you an error because abc is not something that it can use as an integer, right? Okay, so let's discuss the load command in a little more detail. Uh, so all these concepts are fairly simple. So if you have any questions, please keep posting your questions, right? Don't wait for me to stop and ask if you guys have any questions. Just keep posting your questions. So are all of us clear about the data types and the complex data types and so on? Okay, I see two yeses. Are the rest of you awake and with me? Vijay and Dayanand says yes. So I'm hoping that they were listening. Okay, great. So let's discuss the load command in a little more detail. So what is the load command? Load command, so when you say load NYSE dividends, you did not specify the data type or the column names. So it will do the best guessing possible. Tab is used as a separator by default. Absolute or the relative URL will work. If you are in that particular directory, you can just specify the relative URL, or else you have to specify the absolute URL. For example, if I am in this directory, right, I'm already in this directory, so I can just specify the name of any file that's available in this directory. But if I'm not in this directory, then I have to specify the full absolute URL, right? You can also, so suppose the file is a comma separated file, it is not a tab separated file, then you can also specify the separator explicitly saying load NYSE dividends using pig storage comma, right? Okay, so Achinta is asking, so when we were typing the commands before the store commands, so he means when we were typing these commands, divs equal to, grouped equal to, averaged equal to, those commands were not running, or was it running behind the scenes, and was it like running behind the scenes and the results were kept into the memory? No, Achintya, the commands are not being run. Only when you say load or store that or dump, that is only when the commands run. Sorry, when you say dump or store, that is only when the actual execution starts. Until then, no execution is going on, right? Nothing happens behind the scene. Nothing is hidden. Nothing is really happening. As soon as you say dump or store, the actual execution begins. Okay, great. So if the file is comma separated, you can say load NYSE dividends using fixed storage, comma. You can also specify a while character. If you have multiple files which start with the name NYSE underscore div star, you can load all of these files using the wildcard character. You can also, so if you want to load multiple files which are starting with the same name, you use wildcards. So HBase we know is a data store that Hadoop provides. So if you're loading your file from HBase, you can also do that. You have to specify using HBase storage, right? Okay. You can also specify the name and the data types upfront, like we discussed. Also, if you know that your data format is JSON, is in JSON format, you can specify that also. It's saying load second table.json using JSON loader, right? So if the data is in JSON format and you say using JSON loader, you specify the key and the data type. In that way, you can also easily load JSON files. So you can load JSON files, you can load CSV files, you can load tab separated files, and so on. Okay, so when you say explain dataset, it shows a detailed analysis of the query. Like we did a explain here. So Dayanand is asking, in case of unstructured input file, how we can give column names. You need not give column names. If you understand your data, you can give column names. If you don't understand your data, you need not give column names. Pig is going to make a best guess, right? Okay. Sharad is asking, can we use multiple file loads in one load command, right? Sharad, if you have something like this, say you have a uh, folder and underneath you have file 1, you have file 2, you have file 3 and so on. You can say load, you know, uh, yeah, so you can just say load a comma star, right? So it will load all the files which are contained in that input, which are contained in the folder A. But if you want to use multiple file load commands in so yeah, this is how you can load multiple files. You can also give a comma separated list of file names. Right? Okay. So did I answer your question? So at Cubole we provide pig, and a lot of people use our pig offering. What we essentially see is, say they want to process a lot of data which belong to say a particular week, which belongs to first week of July. Then the way they organize their data is they'll keep folders in HDFS for every week, and under that folder they will have all the files, and all they say is, something like what I just showed you, right? So this is how we typically see. This is what we typically see at Cubole. Comma separated in case of different directory. Yeah, I think you can. Yeah, I will have to. Um, you can do that only if you know if your data set is similar, if your data is similar in both the files, right? If both the files have 4 columns and so on, you can't load into a single variable files of different formats, right? One with 4 columns, one is CSV, one is something else. You can't do that. So you have to be very careful. So if you have such a use case, it's better to bring down both the files in a single directory and use that. But you can specify comma separated values in case the files are in a different directory. Ensure that the file formats are similar, because the following commands will work on both the files, and ensure that it is similar. Okay, okay. So you can do a explain data set and it will show a detailed analysis of the query. This is something that we saw already. Okay, you can also do a describe data set and it will show the schema. So when you describe, it will give you the column names and the data types. Right? So I did a describe divs, and this is what it gives me. It will give me the name of the columns and the data type of the columns. Right? There are certain syntax highlighting tools that's available for the IDEs that any ID that you want to use, you can use the plugin for the syntax highlighting. Okay, let's look at the pig in the store and the dump command. Okay, the store command is it will store the data to a file or to other storage. So here we said store averaged into some file location. So it will store the data into some file location. You can also specify the pig storage that you want to use. So if you want to store the data in CSV format, you can say, using pig storage, comma. So here you say store processed into, so processed is the variable, processed in quotes is the file name. Sorry for this, we should have used a proper file name. So store processed into processed using pig storage, comma separated, right? So what dump does you and as per you, store will store the data into another file. Dump will print the value on the screen. So when you say dump, it will only dump the data on the std out, on the standard output. Dump is useful for debugging, right? So it is useful for debugging, etc. So this is the syntax: dump variable. So the moment you actually invoke store or dump, that is when it starts the actual execution. Until then, it is only making notes. Pig is just making notes that, hey, okay, the user wants to store the data, load this file into this and call it, and give it this variable name. He then wants to break the file, group the file, count, and so on. When you say store or dump, that's when the actual execution starts. Okay. Relational operations. Okay, so for each, let's look at for each. So uh, by the name itself, right, we can understand that when you want to process every line in your input data set, that is when you use for each, right? So here you loaded the data into div, and then when you say for each divs generate ticker comma val, right? So what it will do is it will go over every line, and it will only give you the values of ticker and it will only give the values of ticker comma val, only these two columns, right? So for each is basically used when you want to process each line in the data set, right? So we already have, let's just run this, right? So now if I say dump values, it's starting the map reduce phase, and and it's going to give us only the ticker and the val, right? So when you want to process each line in your input data set, that is when you use for each. Let's see the output of this command and then take a break for 10 minutes and come back. See, so this is all it's going to give us. It is just giving us ticker and the value, right? So it went over each line in the data set, picked up the ticker, picked up the value, and started showing it, right? Okay, so let's take a break for 10 minutes and let's come to the time now. It's 8:34. Uh, so the time now is 8:34. Let's come back at 8:44, right? Meanwhile, if you have any questions, post your questions. I will mute myself now. Okay, great. So I am back from the break. Uh, okay, are all of you back? So we looked at for each, right? So what for each essentially does is it will look at it will basically process every line in the data set. Okay, so suppose you load a file called NYSE daily, and these are the column names: exchange, symbol, uh, date, open, high, low, close, volume, adjective, close, and so on, right? Okay, so basically, where do you use for each? If you want to do if you want to do basic operations like subtraction and addition, so you can say for each prices generate close minus open, right? So you're subtracting two values. You can also use positional references. So if you don't want to use the name of the columns, you can also say $6 minus $3, right? So you can say that subtract the third column from the sixth column. You can also specify ranges. So if you want to print, so for example, you want to print exchange, symbol, date, and open, which means you want to print the first four columns. Then you can say for each prices generate colon open, right? So it'll generate everything from the beginning till open. So Akshay is asking, can I do this while storing the data? What do you mean by while storing the data? No. So reading the data and then processing the data using for each are two different steps. So first you load the data. So Akshay, do you mean can you do this by loading the data? No. So you have to first load the data and then you have to do the for each, right? So you say Uh, okay, okay. So if suppose you want to print all the columns between open, high, low, and close, so you can also use something like open dot dot close. So it will print everything which occurs between these two columns, including the two columns. And if you want to print everything after volume, including volume, say you want to print volume and ADJ close, then you can just say volume dot dot, right? So you can use this notation to pick up columns. You can use the direct column names. You can use positional references, right? And you can use the dot dot notation as well. Okay, so what do you guys? Let me just see if. Okay, yeah, we will discuss that. So what do you guys think? Will there be any reducer code generated in this case, for each prices generate close minus open. Will there be any reducer code generated? Okay, so Achintya and Vijay says no. Okay, Achintya says no because it will only it is only fetching the data from HDFS. Okay, so you guys are saying that this is only going to generate the map. It is not going to generate the reducer. Yeah, so it is not going to generate any reducer because no aggregation, no grouping, nothing is being done, right? It is plain simple iteration. Nothing else is being done, right? So let's see an example, right? So here we said for each divs generate uh, ticker comma value. Let's multiply value by 2 so that we can see that some processing also goes on, right? Okay. Uh, Now if I say dump values, see this line is basically what shows. It says that mapper is there, but there is no combiner and there is no reducer. So C colon is empty and R colon is empty, right? So there is no mapper and there is no reducer, right? So only mapper is being generated. Let's okay. Okay, my bad. Let's see if we can see the right. So this is the job tracker URL. Uh, Here we see that there is one map and there are no reducers, right? Since it was not doing any aggregation, it was not doing any aggregation, no sorting, no grouping, nothing. So it did not generate any reducer code. Great, great. Okay, so let's do an so basically we until now we showed for each with simple data types, right? But for each can also work with complex data types. So if you have a file which contains complex data sets, you can also use for each to iterate over that data set. So let's look at this file. So there is a file called baseball. Before anything, let's see what this file contains. So we'll first check if the file is actually here. Okay. So this is not here. We are under what directory? Okay. So we are under user student. Let's go to data, right? And now do a ls baseball. Okay. So we have baseball here, right? Let's do a cat baseball and see what does baseball actually contain. Okay, so we see that the data looks a little complex. Okay, I'm just copying two lines here. I'll copy it here. Okay, okay, so this is it's basically scrolled. Let me just break the lines into multiple. So this is one huge line copied, so I'm just breaking. Okay, so these are the two. I've copied just two records from this file called baseball. So what does this file essentially contain? It contains the name of the player and then it contains, I think, the team for whom it plays. Then it contains what are the positions he can play in. So infielder, outfielder. I'm not a baseball fan, so I might be wrong in explaining the fields, but yeah, this is typically what it explains, right? And then followed by, so we can see that this is a bag, right? Bag is denoted by curly braces. So these are regular character arrays, and this is a bag denoted by curly braces, and then you have this. This is a map which specifies that number of games that this player has played is 297, 5 hit by pitch, the on base percentage, and so on, right? So the number of games that this guy has played is 297, whereas this guy has played only 64 games. So he's a pretty new player. Okay, so this is what the data set looks like. Okay, let's go back. So we will use for each to work with this complex data set. So here when we load baseball, we say that name is a character array, team is a character array, traits is a bag, and bat is a map, right? So this is what bat is, which contains a list of key value pairs. What are the hits? What are how many runs, strikeouts, and so on, right? So okay, so let's load this data. Uh, okay, so I have loaded this data. Okay, let's do a describe on B ball. So it tells me it gives me the value after describe. Now we can say let's work on the okay. So let's get the my bad. Okay. I copied both the columns statements together. Okay, so we have loaded the baseball data. We've specified the name of the columns and the data type of every column, right? So this is done. Now we are trying to find out the batting average for every player, right? So this is the for each statement. So we say for each B ball generate name comma batting average. So see here, the map was denoted by bat, right? And we want to get the key batting average. So this is how we write our data, write our query. We say bat followed by a pound sign, and then the key we are trying to refer to. Okay, so this is done, and then we say dump average. So this is the query that we ran. We are saying for each B ball generate name is this, comma bat pound batting average, right? So there should be a key called batting average. This is the batting average key here, right? Which is for this player it's 0.26. We are just trying to generate that particular. We are trying to get the value of only that particular key in the from the map, right? Okay, so we did this, and this is the output. So here we see that how we can use for each to work with complex data types as well. Okay, so when you want to say you have this input data where you say load input as the data type. So Vijay is saying this is just SQL projection. What do you mean by that, Vijay? Yeah, you are just doing a simple select two columns from the data set. In the previous slides, we saw how we can process the data types. Also, we can do some sort of operations, like here we are doing $6 minus $3. So instead of just doing a plain select using for each, you can also do some amount of processing in the for each statement. Also, it is this might not be very simple with SQL, right? This is not a very structured data. We have the name, the separators, and we don't have the same separator and so on. The map. Yeah, Vijay, correct. In this particular example, we have not done any aggregation. What I'm saying is, using for each, you can do some amount of computation. You will not do any aggregation, yes, but some amount of computation can be done within the for each statement. In this particular example, we did not do anything, right? Okay, so you can also, so if batting average is not present for some players, like here, for this player it is not present, right? It just gives a here I'm highlighting it. So it just gives a comma followed by nothing. Okay. Okay. So you can also do a tuple projection. So if your input data is like this, you can, so there we said map name followed by a pound. Here we say t dot x or t dot $0. You can use positional parameters, or you can use the name of the column. You can also use back projection. So you can say for each a generate b dot x, right? So you can do that as well. Or you can get both the columns. When you're doing a back projection, you can say for each a generate b dot x comma y. So suppose you had a bag where every tuple consisted of 3 columns. You can write a projection where you only where you generate a new bag which contains only 2 columns out of the 3 columns, right? So you can use for each for these, for working with complex data types as well. Okay, so here we see that we use the for each command to work with the columns, right? We did some processing with the columns. So here we are saying for each divs generate dividends into 100 as dividend and dividends into 100. So basically we can, also say something like this. So if you have, if your data contains 2 columns, which is x comma y, you can also say for each my data generate sine of x into sine of x plus cosine of x into cosine of y. So you can sorry, yeah, so you can do such processing within the for each command. So there is, you can look in this, you can take a look at this link. It will give you the other built-in functions, right? You can go through these built-in functions. These are fairly easy to understand. Yes, Manoj, it is okay if some players do not have a bag at all, right? In fact, what you can do is you can download this baseball file locally, read some sample, read some 10, basically copy some 10-15 lines into a local file on under your folder, and you can run. You can then upload this small file again. You can specify a new line which does not contain a bag at all, and you can see for yourself what happens. Try to run this same for each query, the same pick command, and see what exactly happens, right? Okay. Okay, so the next thing that we are going to look at is the group by. Um, Vijay, yes, you can practice the pick commands in local mode. The only thing is that you will not see the map reduce phase, but you can definitely practice the pick in the local mode. It is, in fact, a very good practice. You can see you don't have to wait for your map reduce phase to kick in and then complete, and it's not very time taking. You can quickly use some sample data set and practice pig in the local mode. This is really used for just learning pig and debugging pig and so on. Okay, so the next thing that we're gonna look at is called group by. So what is group by? Group by essentially is when you have so think of a MySQL table where you have some columns which are similar, and you want to group all the other columns based on this single column. So you say basically that group all the values of all the rows where the column value is this value, right? So suppose you have mm, table called a table which has name and the city, the name of the person and the city, and you want to get all the people who have the who belong to a particular city. So you will basically do a group by city, right? So you can group items on K. So consider that you have this data set A where the format is like this. It contains the name of the person and the age and the GPA of the person. And if you want to group all the people by age, basically you want to find all the people of a particular age. Uh, what are their details? You say something like this: group A by age. So it is very simple to write a group query in Pig. So this is what the output is going to look like. So when you say this, your first this thing, right? Your first column in every row is the age followed by the whole value, right? So it contains basically a map of the values. Sorry, it contains a tuple of these. Yeah, so it basically contains a bag of this of these tuples, right? So let's quickly do this example and we can see it for ourselves. I'm not sure if this okay, this mm, um, let's see if we have some data set. I'm seeing if we have some data set where I can show you this example. Okay, never mind. We can. Okay, let me go to my directory. Okay, so I have this thing in my local thing. So I will run. I have this file called city in my in the local file system. So I'm running pig in the local mode, right? So what we are first going to do is we're going to say city is equal to load city. Okay, so this is loaded. Right, so I got my city. Then I will say group. Okay, since I did not give the names, right, so I'll just say group city. uh, I did not give names to my columns. Let's see if this works, right? Okay. Okay, this is not a very good example because this file is not even tab separated, so it's not able to pick. No problem. Let me see what this has. Okay, so we can use this, right? So okay, so I will say owners is equal to load. What is the file name? Owners.csv using pig storage. Right, so I'm loading owners data. If I dump owners, it's not going to be, it's just going to dump the data. Okay, so this is the data. Now I can say group is equal to group owners by 0. Okay, I again did not give names to my columns, so I'm just using positional reference. Right, I will do a dump group. So this is the group, and when I say describe group, this is what I get. Okay, so let me just show you what owners look like again. So this was my file. It contained the name of the person and the kind of pet that it owns, right? So Adam owns a cat and Adam owns a dog. Alex owns a fish. Alice owns a cat and Steve owns a dog, right? So this is a simple file. What I did was I loaded the file and then I said this group owners by $0 by the first column, right? So this is the output that I get. So we have the name of the person followed by the entire tuple, right? The bag of the tuple. So followed by Adam dog and Adam cat. So when I do a describe group, I see that the first column is always given the name group. This is what pig does. So first column is given the name group, which is a byte array, and owners followed by owners, which is a bag of tuples, right? So this is what pig does. The first column, it always gives it the name group. Right, so in this example, when we do it, and when we do a describe B, we see that the first column group is of type integer followed by A. It gives the name of the the data set on which we were trying to group as the second column, which is a bag of tuples, right? Any doubts here? Do all of us understand group? This is a fairly simple concept to understand. What about the rest of you? I don't see the rest of you saying a yes or a no too often. So it'll be good, it'll just let me know that, all of you are awake and following. Okay, great. Great. So flatten is used to So Manoj is asking, once we have executed a group by 0, can we also execute a group by $1? Yes, you can execute a group by $1 because the real data set has not changed. So this is Manoj. I will just try and do this. I'm not loading the data set again. I'm just saying I will now call it group 2, whatever. Right, group owners by $1. Right, now if I say dump grp2, it's gonna dump that data, right? So here it grouped by column 1. So cat, dog, and the fish becomes the key. And because it did not modify the initial data set, so we can group again. That's a very good question, Manoj. Okay. So we can now use flatten also, right? So What is flatten? So in flatten, you get the input data set in this format. So you say the name of the person and the kind of um, languages he understands, right? He can write. So Sandeep can write C, C++, Arun can write shell and C, and so on, right? So you can flatten the data and you can get something like this, right? So okay, so let's do it. So the thing that we just did, right? Our data set is already in this format. So we have this dump grp, right? Which is something of this format. So let's run the flatten command on this particular uh, variable or this particular file. If we put this into a file, it becomes a file, right? So let's do this on this. So we say for, okay, let me first show you what we do. Okay, so this is what essentially we'll do. We'll so we've loaded the okay, we've loaded the file. So we load the file and then we say for each x generate name comma flatten the languages, right? So what it will do is it will put one language per name and put them in different files. So it's going to basically flatten the file for you, right? So we will do the same thing here. So we will say for each group, this is the group data set, we'll say generate $0 comma flatten owners, right? So when we do a dump FLT, yes, yes. So Vijay actually saw what we are doing. This is the opposite of aggregation. This is the opposite of group by, right? So here if I here I took $0, but if I say I just get rid of $0 and then I do a dump FLT, this is what I get, and the original data set that we used was this, right? So we basically get the same thing back. So flatten is just the opposite of group by, right? So all of us understand flatten. So if you have a data in this format in the lower right side corner, if you have the data in this format and you want to group the data based on the name, you use group by. But if you have the data in the format which is shown on the top left corner and you want to basically break this, flatten out this file, then you use the flatten command. So basically they are just the opposite of each other. I showed you this example by working on the same file, owners.csv. Right? If you guys want to try this command, I think this is in under the data folder also, but if it is not there, then you can copy it from my folder. Let me start in the Hadoop mode. Okay, great. So I'll move ahead. Okay, filter. So filter is another command that MapReduce has. What does filter essentially do for you? It basically lets you filter out the data. So you load the data and the regular expression, so you can say something like this: filter divs by symbol matches cm dot star. What do you think is this cm dot star? Can anyone tell me what does cm dot star mean? Okay, anything which starts with cm. Okay, Okay, so cm dot star basically means anything that starts with cm followed by one or more characters, right? So it's essentially anything that starts with cm. This is a regular expression way, right? So let's quickly oh God, this doesn't even copy properly. Let me just run the load command again. Right? Uh, okay, so which let me just say dumb divs, see what it comes. Okay, so this is regular expression. Then you can also say filter divs by not symbol matches cm dot star. So okay, Manoj, no Manoj, it is not cm dot. It is starting with cm dot star is basically a regular expression which says 0 or more, right? So cm followed by 0 or more characters. So what I will advise is that we have in the first session you will see that there is a quick small video on Unix regular expression. It'll be good if you guys can go over that regular expression, right? Okay. See, so this command basically failed when I said load and when I said dump. This failed, but you will not see the error unless you say dump. Now the data was not even in this folder, so we have to change the folder. Then we have to say load divs. So unless and until you run divs, you don't even see things like file not found. So I'll say a dump divs now. Okay. You can also filter by logical operators. You can say filter divs by where dividends are greater than 0.10 and dividends are less than 0.12 or dividends are greater than zero point 0.4. So you can basically use logical operators to filter the data. So you can use regular expression, you can use negation, you can use logical operation, and so on. Okay, this is running the map reduce job. Okay, so this is the data. Let's quickly run a simple filter to see how filter works. Right, so I'm just running this filter command. Now I'll just say dump starts with cm. Right. Okay, let it run. We'll come back and see. Okay, let's answer this question. Will there be any reducer code generated for this? Start with CM, filter divs by symbol matches CM colon star. Do you think any reducer code will be generated for this particular command? Okay. Achinta says no. Okay. What about the rest of you? Yes, yes. So the answer is no, right? There is no reducer because there are no aggregations done, right? Okay. So this was the output of that cm command. Regular expression where it matches cm dot star starts with cm. So it now shows everything that starts with cm. Also, what we can see here that it start here that there is a mapper, but there are no combiners and reducers, right? So there are no reducers because there are no aggregation done. Okay, Manoj is asking, is it possible to hide all the system messages and only show the output when you run the commands? No, Manoj, you can't run pig in that mode. It will show you the map reduce stuff. If you want to just see the output, you basically do it in the form of a pig script. You write all your commands in a pig script. You specify a output location, and in that case, you can just go and see the output location, and you can just ignore the pick commands, because if something fails you really want to see the logs to see what went wrong. Like I just ran this query and I was not in the correct directory and it gave me an error, right? So you have it shows the logs. Okay, great. Okay, so then there is order by and there is distinct. So order by is fairly simple. Order by basically orders the data based on the column that you have specified. So here we are saying order divs by symbol comma dividends descending. If you don't specify descending or ascending keyword, by default it will order the data in ascending. Basically in the ascending order. You can also you can order by just one column or you can order by multiple columns. Like in this example we are saying order divs by symbol comma dividends descending, right? Okay, then there is distinct operation. So basically you can also get the distinct values. So you load this NYSE dividends data and you say for each divs generate symbol. So first we have got all the symbols that were there, right? The ticker, this thing, CMK, CMU and so on. And then you say unique symbols is equal to distinct symbols. And then you just dump unique symbols. So what this is going to give you, this is going to give you all the distinct values of the symbols. I need not run this command and show you. It is a fairly simple command. Go back after the session and try and run these commands. Okay, so a quick question here. Is this gonna generate any reducer code? What do you guys think? Unique symbols is equal to distinct symbols. Will this generate any reducer code? Okay, I see that my class is really following. Most of you are saying yes. Why the ones who are saying yes, why do you think it will generate any reducer? To remove duplicates, to find distincts, it has to see all the values from different mappers, need to check if the key already exists. Aggregation is happening at distinct command because now aggregation will happen to find the, yes. So this is going to generate reducer code. Why? Because it has to sort the data, right? We saw when we were running Unix shell commands in the second session, we saw that we do a sort and then we do a unique to get the distinct symbols. So internally, it has to sort the data to get the distinct symbols, and hence reducer code will be generated. For every key, it will see that if that key is already generated, right? So it is gonna produce reducer. Okay. Okay. So the next very useful utility that pig provides is the join, right? Join is why pig is used over MR, right? Join is why we tend to use a pig so heavily over MapReduce, because it is very difficult to explain joins, to express joins in MapReduce. Therefore, we tend to use a pig very heavily because it is very simple to do joins in pig, right? So joins, since most of you are comfortable with SQL, you guys already understand joins. So you can join the data on a single key. For example, in this, we are loading two files, NYSE daily and NYSE dividends, and then we are saying join daily by symbol and divs by symbol 1. So here uh, we are joining on one column. So we are saying join one table on one column with other table on another column, right? So this is the way we join. We say join daily by symbol and comma divs by symbol. So consider daily and divs are table names and symbol is what you want to join on, symbol and symbol 1. right? You can also have composite joins. So do you guys want me to quickly run this and show it to you? I can do that. So I'm not gonna. Okay, uh, I actually just wanted to do a quick explain and show. I'm not gonna dump, so I don't want. Right, and then I say, right now when I say explain JND, not explain, I'll say describe. Describe JND. See, this is what the output is going to look like. You guys can run this on your own and see, but this is what the output is going to look like. It will contain all the values. So it will contain exchange. So daily here is the table name. For exchange is the column name, and byte array is the type, right? So it will contain all the columns from the first table. I'm just calling it table daily, followed by all the columns from the second table divs, right? And the columns will be such that the value matches. Right, so you can also have composite joins. So sometimes we have cases where we want to do a self join. You must have done it in MySQL, right? Uh, so for example if we want to find out all. Okay, for example, if I want to find out for each stock, find dividends that increase between two dates, right? So we want to join on the. Okay, we want to first join on the stock, and then we want to see what are the stocks whose dividends increased between two dates, right? So you can't, so basically you just have NYSE dividends table from day one and from day two, and you want to do a self join, but you can't do a self. So basically when you want to do a self join, you'll have to load the data twice. You cannot say, div join div, right? So you can't do that. Okay, so you say divs 1, then you again load the data, say divs 2, then you join divs 1 by symbol, divs 2 by symbol. Once you have this joined data, which will contain the values from all the columns in both the tables, essentially, you can say filter JND by divs colon date, right? So I just showed you this is how it looks like, daily colon colon exchange. So here divs 1 is the table and colon colon date is the name of the column. So this is the way the columns are denoted after the tables are joined. I am just using the word table here. These are not really tables, these are data sets. Okay, so this is how you do a self join. Okay, so these are the differences from a regular relational database. You always have to join on a column, right? Like in MySQL, when you run SQL queries, you can just say, select star from table A, join table B, right? You have not specified any column, but here you have to specify a column. And joins cannot have conditions. You cannot say that, join A comma B on A dot value greater than B dot value. You cannot do that. If you want to do something like this, you have to first join A and B on some on something, and then you do a filter, right? Like we did in the previous. Like we did in the previous slide. Yes, Dayanand, we have left join, right join, etc. We will discuss it in the further slides. Okay, okay. So this is basically just an example. So this is the name, this is the contents of the two files, right? And when you say join A by ID, B by ID, this is what you get. So you get, uh, so here I said you get all the columns from all the tables, right? So here you get 1 comma Sandeep and 1 comma Giri, right? So this is what you get. Okay, so left join, this is what Danan was asking. So you can, okay, so when you do a left join, what does a left join essentially mean? Can any of you tell me what is a left join? Okay, Achintya says all values from left table. Yes, yes, yes. Correct, correct. So, yes, it'll match, it'll definitely match the common values from both the tables, table 1 and table 2, but it will also give you all the values from table 1, from the left table. It will give you all the values irrespective of whether there is a matching value in the right table or not. So basically it gives you all values from the left table and the common values also. So here when we do a left join, we say we get 1 comma Sandeep, 1 comma Giri, and we also get 2 comma Ryan, right? Although there is no matching value in the right table, uh, but that is essentially, but we just take that, right? Also notice that the keyword left outer or left should occur before the comma, right? So here we say hello join a by id left outer b by id, right? So when you say a, so not a, let's say c equals join a by id, you have to say left or left outer, then give a comma and say b by id. It has to always, the keyword always has to come before the comma, right? Okay. Similarly, we have the right join, which gives us all the values from the right table, irrespective of it having a matching column with the left table or not. So it will give us the values which match. So we'll get 1 comma Sandeep and 1 comma Giri, and we will get all the values from the right table. So here we get 3 comma Saha. Okay. Okay, so suppose you have to do a right. I think there is some problem in the way slides are. Okay, what will be the output in this case? Can any of you tell me what will be the output? So we are doing a right outer join here. What will be the output? What will our O look like? This is fairly simple. Can we have answers quickly? Yes, yes. So this is basically what we are gonna get. We are doing a, so we are doing, oh God, what am I doing? Yeah, so we are doing, we'll get a 4 comma Giri and 4 comma Ryan from both the tables because they match, and since we did a right outer join, we'll get rest of the values from the right table, right? So then we'll not get Sandeep here because Sandeep occurs in the left table and it does not have any match, so we will not get Sandeep. We will only get 4 comma Ryan, 4 comma Giri, and 3 comma Saha. So do all of you understand why we are not gonna get Sandeep? Any doubts? Because I see a couple of you said we'll get Sandeep as well. We are doing a right outer join. So we pick up the, when the first value in from the first table is picked up, We check if it has a matching value in the right table. If it does not have, we just discard it because it is not a left outer join, it is a right outer join. Then we pick up 4 comma rhyme, we see it matches something, so that comes in the output. Once that's done, all the other values of the right table are just printed as is. Right? Any doubts on why 1 comma Sandeep is not going to occur? Okay. Okay, great. Okay. So this is a full outer join. What happens in a full outer join is we do the join. So we get all the common values and we get all the values from the left table and all the values from the right table which do not have a matching value, right? So here we get 1 comma Sandeep, 1 comma Giri because the ID 1 matched. But since this ID 2 did not have a corresponding value in the table B, but since it's a full outer join, we're just going to get it, right? So this is a full outer join. Okay, so what will be the value of this? So when we say join A and B by ID, we get N1 records. When we say left join, then we get N2 records. And when we say right join, we get N3 records. So what will be the answer for the last one, for the full join? NN. Okay, I have two answers. What about the rest of you? Yes, Manoj, but what will be the number of those records in terms of N1, N2? Okay, okay. So it is going to be N2 plus N3 minus N1, right? It's not going to be N2 cross N3, not N2 by N3. It's going to be N2 plus N3 by N1. Why? Because when we do a left outer join, we know that all the values from the left table are going to come, right? So by virtue of that, we know that the left table has N2 records, right? Similarly, by virtue of the third query, we know that the right table has N3 records. So we know that the number of records in N3 and, the number of records in the table A and table B is N2 and N3, right? Because the left join gives us all the records from the left table, from table A, right? So it has N2 records totally, right? So we know that A plus B is N2 plus N3. And since it's a full outer join, all the common values needs to be removed, right? Because we will get the common values only once. We will so N2 plus N3 will have accounted for the common values as well. So we have to subtract N1 records. So am I clear? How did this come? Why is it N2 plus N3 minus N1? Okay, okay, great, great. Okay, so quickly, what will be the output of this command? Read the query very carefully and then answer. Yes, yes, correct. Achintya has an answer. What about the rest of you? No, basically this should error out. The left or the left outer should be before the comma, right? So I explained in the previous slide, I specifically pointed out that the keyword left comma or the left outer should come before the comma, right? Here it is afterwards, and hence this query is gonna error out, right? Okay, what will be the answer for this? No, this query is gonna error out again, right? This query is gonna error out again. Why? Because there is no join called outer join. We saw full join, left join, right join. We saw left is also called left outer, right is also called right outer, and then there is a full join. There is no join called just outer join, right? So this query is gonna error out too. So these slides are just to make sure that you guys are listening to every word that I'm saying. So the keyword has to come before comma, and the keywords are just left, left outer, right, right outer, or outer. Sorry, or full. There is no outer join. So this is gonna error out. Okay, great, great. So all of us understand joins, right? Joins are a fairly simple concept in Pig, and the good thing is that it is so easy to depict joins in Pig, right? It is not at all complex. Okay, so there are other two commands given by Pig called limit or sample. What limit does for you is limit is going to give you, uh, uh, you can say it's going to give you a fixed set of data. So you can say, limit divs 10, so it's going to give you the first 10 rows, right? Limits and sample, what is sample going to give you? You say sample divs 0.1, so it's going to give you 10% of the records. Zero point 0.1 into 100 is 10, so it's zero point 0.1 of 100% is 10%, so it's going to give you 10% of the records. Also, the records are going to be, in case of sample, the records are going to be fairly random. Pig decides, what sample data set is it going to give you, which 10% of the data is it going to give you. When do we use limit and sample? Suppose you're working with huge amounts of data and you want some sample data to test out your program. In that case you can use a limit or sample, right? You can do a limit or sample, put the output in some file, and then use that file as a input to your test program, right? Limit gives you a very skewed data. It does not give you a very good picture. Suppose your input data set is already sorted and you do a limit 10, then you will get the first 10 smallest values, right? You will not get a very randomly fairly distributed data. If you want a fairly random distribution, then you should use sample, right? Okay, so if to answer this question, if we do this, we load the file and then we run, we say sum is equal to sample divs, and then we dump sum twice. Will it give the same output or will it give different outputs? Yes, yes. Most likely no. Most likely it will give us different output. Yeah, and we know that it runs it exit when you say dump sum, it will run the map reduce code twice, and since it's a sample, it's going to give you a random sample. So most likely it's not going to give you the same output. If you want the same output, then you should use limit. If you say limit 10, it's going to give you the first 10 rows every time. Okay, okay. So pig gives you a lot of pig gives you some knobs to control the number of reducers, right? Uh, okay, so okay. So the basic promise of pig is that it is parallel, right? We initially said in the first few slides that pig is uh, pig executes your commands in parallel, right? So you can use the parallel keyword, and it will help you control the number of reducers, right? So pig gives you knobs, pig gives you controls to specify the number of reducers. It does not impact any mappers. Obviously, pig is parallel keyword is only used to control the number of reducers, not the number of mappers. Also, you can use it only with the functions which actually need reducers. For example, if you do for each generate something something parallel 10, that will not make any sense because it does not generate any reducers, right? Here in this example, we say group daily by symbol parallel 10. So it will create 10 reducers for you. Right? The map side logic is not controlled with this. Only the reducer side logic is controlled. Only the number of reducers. Okay. Also, if you want 10 reducers for every command that will generate that will result into reducers, you will have to give a parallel 10 with every command, right? So that becomes a little cumbersome. So if you want to have all your command generate 10 reducers, then what you can do is you can say a script, you can set script wide. So say you've written a script which has a number of commands. Some of these commands will generate reducers, and you want 10 reducers to be generated all the time. Instead of repeating the parallel 10 keyword every time, on the top of the script, you can just say set default parallel 10, right? So the default number of reducers for the entire script will be 10. If, however, you don't specify parallel, like in most of our codes, we have not specified parallel, then what does pig basically do is based on your input data set, right? The input that is fed into the mappers, based on that input data set, it will try to count the number of reducers. So say you have a 5 GB data set that you're trying to process. For every 1 GB, it is going to generate one reducer. So there will be 5 reducers, right? Suppose you have 2 terabytes of data that you are trying to process, then will it generate 2000 reducers? No, it will not generate 2000 reducers. The maximum number of reducers is limited to 999. So if you have until 999 GBs of data, it will generate 999 reducers, and over and above that, it will just limit it to 999 reducers. So how is this input? So it looks at the initial file size, right, irrespective of whatever data goes into the reducer. So in some cases, may assume that the initial file size is fairly large, but the mappers process the data such that very small amount of data goes into the reducer, right? In that case, also the number of reducers are very large because the reducers are decided based on the input size and not based on the data that goes into the reducer. Based on the input that comes to the mappers, it will try and decide the number of reducers, right? If you don't specify the parallel 10 um, keyword. Am I clear? Did all of you understand the parallel keyword? Yes, Manoj, group by creates reducers because it does a aggregation, right? Okay, can you guys answer this question? How many reducers will it produce for this particular command? For each divs generate symbol, comma dividends 0. Yes, yes, true, true. It will not generate any reducers. I asked the same question in the previous slides also. It will not generate any reducers because no aggregation is being done. So I think that is fairly clear, right? Okay, answer this. Does parallel clause have any effect on this command? No, right, because parallel controls only the number of reducers, and since there are no reducers in this command, since reducers will not be generated for this particular command, parallel keyword will not have any effect, will not take any effect. Great. Okay, okay. So suppose, at times you already have, so we looked at, things like group by and all of that. Sometimes you want to use some built-in. mm, Okay, sometimes you want to use some built-in data types, some Java built-in data types. Suppose you have some Java class on your machine, right, which has this method invoke for string. Okay, invoke for string, which basically converts the integer into uh, a hex. Okay, a hex value, right? And you want to invoke this string. So for every so suppose you load this NYSE data set, and for every uh, uh, column value, sorry, for every volume, for every value in the volume column, you want to convert it into hex, right? So you can use this Java built-in data type. You can say for each divs generate symbol comma hex int of so int. Why are we specifying int? Because in the previous load command we did not specify the data types, right? So took everything as byte array. So we first typecast this byte array into integer, and then we pass it into the method hex, right, as an argument. Had we said load NYSE daily, suppose we had given the data types and we said the data type for volume was int, then this typecast wouldn't have been required. We could have just said for each divs generate symbol comma hex of volume, right? So in the what we said is define hex invoke string. So here we are defining hex, which is basically this method, right? And then we are just passing the value of the volume column into this method, right? Pig also lets you write your own Java function. I will show you the syntax in tomorrow's class, okay? But you can also write your own Java functions, and you can use those Java functions, right? So here we have written our own jar called acme.jar, right? And then we say similar. So here in the previous example, we were using some Java built-in functions. Here we've written our own jar. So first we register that jar, and then we define this method. We say define convert as this method. Basically, we are using this class, and we are passing these two parameters and so on. So we convert is basically a currency converter, and then when we call this convert in this last command, backwards is equal to for each divs generate convert, we are passing this xcch. What it's going to do is it's going to convert this dollar value into euro value, right? So this is how you can write your own Java functions. We will write a quick Java function tomorrow. We will see how to export it into a jar and how to use that Java function with pig, right? So this example will become more clear after that. You can also have Python functions, right? So if suppose you have written some Python script, and you can also use that Python script to process your uh, data, right? So here we are seeing we've registered some Python script file, and then we are saying for each non-null generate name comma bball dot production somval. So bball is basically we registered our Python script as bball. There is a method called production here, so we are saying bball dot production. We are invoking that function and passing this some value as the parameter. Okay, so what you can do for tomorrow's class is you can basically, if you go to my courses, uh, if you go to big data, go to session 5, and here you can you can download this big udf.java, right? Import it into your Eclipse or whatever IDE you are using, right? And we will look at the code in tomorrow's class. We will see how we can generate the UDF and how we can register the UDF and so on, right? So let me quickly see what's left for tomorrow. So we will discuss about UDF, big streaming. Okay, okay, great. So tomorrow's class we will discuss about Pig UDFs and some more concepts in Pig and then Hive. Okay, so Sharad is asking where will we define the custom Java function? No, since it's a Java function, it will be a Java class that you have to write. So remember when we were doing this map reduce code, we wrote this mapper and the reducer classes, everything, and then we exported that map reduce entire package into a jar file, and then we used that jar file, right? Similarly, we are going to write a Java program. We're going to generate a jar file. We'll write a Java program which will contain a method, right? So similar to this, we will write some Java file which will have some method. Like here, there is a currency converter, and then we use that method, right? So it will be a Java code. It will not be a Pig script. It will be a Java code, and we will use that Java code in our Pig script. Okay. Okay. So meanwhile, what you guys can do for tomorrow's class is when you can have this Pig UDF downloaded, etc. You can take the basics, the Pig basic quiz. You can also start the subjective quiz. Take a look at the quiz. Try taking a stab at the basic quiz. There are a few concepts which are still left to discuss. We will do that in tomorrow's class. Okay. Any questions for today's class? Any questions around today's session or the last session around map reduce? I've got some really good set of questions, and looks like all of you were wide awake and following, because I got almost right answers. I got right answers from almost everybody. Uh, so that's the intention of having so many questions in between the slides, to ensure that all of you are following the class. So any questions for today's class? What forum, Vijay? Yes, yes, yes. It does get monitored. Yes, yes, you should do that. So if you have any question, you can put it in the discussion forum, and someone is going to reply to your question. Right? If you have any questions, you can also send it to hadoop@nobigdata.com. But yeah, it'll be good if you can post your questions in the discussion forum. Okay, okay, great, great. It was great connecting with you guys today. See you guys tomorrow. We'll discuss more on Pig, and then we'll start Hive. Also, go over the slides, and for every small command that we ran, right, all these filter, limit, sample, group by each, order, etc., try running it on in the local mode or in the Hadoop mode. Run these examples until and unless you do a hands-on, you'll not get the feel, right? So try running all these examples. Cool. So I'll end the webinar now. Okay. Yeah. Bye. Bye.